Hello students, in part 2 we already discussed about the structure functions of glucose. In part 3 we are going to discuss about monosaccharides like fructose and galactose. Fructose and galactose. Part 3. Fructose. It is a carbohydrate and contains 6 carbon atoms. It shows levo-rotation, hence it is named as levulose. It has keto group at C2, hence named as ketohexose. It has 3 asymmetric carbons. You know that there are 4 asymmetric carbons in glucose, but in fructose, why there are 3 asymmetric carbons only? Because first and 6th carbon in fructose are CH2OH, that is a primary alcohol groups. They are non-asymmetric. Hence, fructose contain only 3 asymmetric carbons, third one, fourth and fifth. C double bond O is a carbonyl group which is present at C2 in fructose, which forms ketoacetal linkage with 5th carbon or 6th carbon in cyclic structures, and C2 changes to asymmetric carbon atom named as chiral. Do you know the meaning of chiral? Chiral means hand. It is a newly formed asymmetric carbon. When OH is present on the same side of the linkage, is named as alpha isomer. OH group is on the opposite side of the hemi-acetyl linkage, is named as beta isomers. You know that is also discussed in structure of glucose, which is similar like glucose. Both the isomers, what is the name of these isomers? These isomers named as anomers. The number of asymmetric carbons also increased from 3 to 4 in cyclic form. Why there is an increase of asymmetric carbons? Because the first carbon in glucose, we know that may be changed to asymmetric. But in fructose, in case of fructose, the carbonyl carbon is present at C2. In open chain structure, C2 is a non-asymmetric because it contains double bond with O. Here in cyclic form, this can be changed to asymmetric by the formation of hemi-acetyl bond. Hence, the asymmetric carbons increase from 3 to 4. Now, we are going to analyze the structure of fructose in detail. First, open chain structure. The first and 6th carbon in open chain structure shows that CH2OH. CH2OH means primary alcohol. The second carbon, C double bond O, which is a carbonyl group present in fructose. Third carbon bears OH on left side, fourth and fifth carbons bear the OH on right side. If the penultimate asymmetric carbon, which is a penultimate asymmetric carbon in fructose and glucose, that is fifth, that is adjacent, that is CH2OH. The fifth carbon, which is very important to identify the configuration of the fifth carbon, that is OH and H configuration on the fifth carbon is very important to identify D and L family sugars. Here on fifth carbon the OH is on right side, that means it is a D family sugar, hence it is named as D fructose. There are two cyclic forms. These are furanose forms, that is pine-tar ring. This ring containing 4 carbon atoms and 1 oxygen atom. The first carbon configuration is very important to identify the alpha and beta isomers. OH, which is projected towards bottom, that is indicated by pink color, that indicates that alpha D fructofuranose. In second cyclic form, you observe that the OH projected towards the upper side, that indicates the form of cycle is beta D fructofuranose. Here another structure in detail. We are numbering also. The carbons are also given numbers to identify easily. You see that the second carbon C double bond O in open chain structure. And fifth carbon, the OH is on right side, that indicates D fructose, which is a linear. If the OH is present on the fifth carbon towards left side is L fructose. Here in the cyclic form, you observe it is clearly that OH projected towards the bottom, that is downward side, that indicates alpha D fructofuranose. Sources of fructose. Inulin is a polysaccharide which is a very important polysaccharide used for the renal function test. This polysaccharide on hydrolysis gives approximately 30 D fructose units. And other sources are sucrose, fruit juice, honey, etc. Properties of fructose. 1. It is a sweetest sugar and soluble in water. It is a levorotatory. Its mutarotation is minus 92 degrees. It reduces Benedict's reagent and Fehling's reagent. It forms ozones with phenyl hydrogen hydrochloride and acetic acid. On reduction, it forms D-mannitol and D-sorbitol. On oxidation, it forms mesotartaric acid and glycocholic acid. You know that glucose on oxidation forms 3 different types of products. Mild oxidation, it gives gluconic acid. By strong oxidation, that is agents like nitric acid, concentrated nitric acid, it forms dicarboxylic acid, saccaric acid. In special oxidation with hydrogen peroxide, it forms uronic acid. But here, in case of fructose, the only one type of oxidation, that is gives 2 important products, mesotartaric acid and glycocholic acid. It can be changed to glucose in liver and intestines. Clinical importance. Present in seminal plasma. It is a component of sucrose. In fructose metabolism, it is directly converted to lipids to produce hyperlipidemia, and which leads atherosclerosis, that is thickening of arterial wall, because of the deposition of lipids on the inner side of the artery wall. This condition we named as atherosclerosis. It is possible in cases of hyperlipidemia, especially hypercholesterolemia, and high fructose content diet is taken. The deficiency of enzyme fructokinase. Do you know what is a fructokinase? Fructokinase is an enzyme involved in fructose metabolism, which leads essential fructosuria. The deficiency of another enzyme that is also involved in fructose metabolism is aldolase B, which leads hereditary fructosuria. Galactose. It is a carbohydrate and contains 6 carbon atoms. Aldehyde group at C1, the aldehyde group is present at C1 carbon, hence it is named as aldo sugar. It gives pentaethyl derivatives, indicate that 5 OH groups on 5 carbon atoms. The aldehyde group reacts with OH group of 4th or 5th carbon to form hemiacetyl linkage, which is similar to that of glucose. The OH group at 4th carbon is on left side, whereas in glucose it is on right side. Here we are going to analyze the structure of galactose first. Galactose is a aldo sugar, hence the first carbon being a carbonyl group CHO, and 6th carbon is a primary alcohol CH2OH. See that second carbon bears OH on right side, third carbon on left side, fourth carbon also bears the OH on left side, fifth carbon which has OH on right side, hence it is a D-galactose. You observe the difference, you compare the structure of D-galactose with D-glucose. You see that the OH on fourth carbon is on right side in glucose and left side in galactose. Properties: it is soluble in water. Glucose and galactose are epimeric pair with respect of fourth carbon. It forms ozones which are differ from glucose in shape, irregular flowerlets. It is a dextrorotatory, non-fermentable sugar. It forms insoluble mucic acid crystals and boiled with concentrated nitric acid. It reduces Benedict's reagent and Fehling's reagent, hence it is a reducing sugar. It reduces Benedict's Barfield's reagent, hence it is a monosaccharide. Physiological role of galactose: it is a component of lactose in milk, hence it is named as milk sugar. Galactose is a structural component of keraton sulfate, a mucopolysaccharide. In liver, galactose is converted to D-glucose. The deficiency of enzyme galactose 1-phosphate uridyl transferase, which is involved in galactose metabolism, leads to the accumulation of galactose in blood, produces galactosemia. In this case, galactose reduced to galactitol and accumulates in eye lens and produce cataract. This, and not only cataract, in some cases we can observe the liver failure and mental retardation also. Thank you.